Hello learners, I hope the studying for geography is going well. I know you've written your science papers and now you're going to write your maths papers, and sometimes we tend to neglect our geography, but I hope you are still keeping in contact with studying it. Today we're actually going to look at some typical exam questions on climatology. But before I even look at those exam questions, I just want to highlight something that seems to be a huge problem amongst our learners, and that is not using the source material properly. I don't know why. We call it trigger happy. Students tend to forget the source material and just go straight to the questions. So beside looking at the answers to typical exam questions, I'm also going to focus on how we can actually use the source material and also find various answers in the source material itself. So let's get going. All right. Let's look at the first question that I have here. All these questions have been taken from the 2011 November paper. And let's look at it. Obviously, as you can see, it says refer to figure 1, which shows a tri-cellular model. Already it's focusing or zoning into a section of climate that you have studied. Select a label from the sketch that best suits the statements below. So obviously it's going to be statements and you select. But before we even look at the questions itself, it's very, very important to look at what the diagram actually gives us. And when we look at it here, we clearly can see the 3 cells clearly labeled on the diagram. Okay? It also gives us the polar front, which is found between the ferrule and the polar cell. And of course, that's meeting of the warm and cold air mass along that front. And then clearly we find the equator and the pole. Okay? And at the equator we can see a strong convergence and rising of air. At the equator we can see a subsiding of air. So it gives us already quite a bit of information. Then, if we notice, also it talks about pressure belts. And we know that at the poles we have the polar high, all right, at the 60 degrees the subpolar low, and at the 30 degrees the subtropical high, and at the equator the equatorial low. Now please note, the information given here is very specific. We can't just add information that's unnecessary. So a lot of this information will be relevant to the answers. So let's then look at the questions and we'll see how they fit into the source material. Let's look at the first one. The zone of convergence for the meeting of warm and cold air mass. And already when we looked at our diagrams, you see the warm air mass coming from the subtropics and the cold air mass coming from the poles. And obviously it meets at this section. And there's your answer already. So it's simple that we actually use the diagram and we found the first answer, which is the polar front. Okay? Let's look at the second question. The cell is the weakest of the 3 cells. We noticed last year in the exams that this question gave people difficulty. When they looked at this question, they looked at the size of the cells, the Hadley, the ferrule, and the polar cell. And what did learners do? Because the polar cell looks the smallest on the diagram, they decided that that was actually the weakest cell. But please note, learners, if this sort of question comes up again, we need to know our information surrounding the cells. The Hadley cell is heat generated. So is the polar cell. Heat generated. Here, the Hadley cell, the air is hot, it rises. Here, the air cools and it subsides. This ferrule cell actually forms because of the movement in these 2 cells that are heat generated. So it's not weakness in terms of size, but it's weakness in terms of it's not being generated, it's not having its own energy. It's formed between these 2 cells. So therefore, in that case, the weakest of the cells is the fertile cell. Okay? Let's look at the next question. The formation of this cell is due to high surface temperature. And again, we can get the answer from the diagram. Let's look at this. We know that the region with the highest temperature is the equatorial region. And which cell is found in the equatorial region? It's the Hadley cell. So, very easily, then we know the answer is the Hadley cell. Please note, I'm actually finding most of my answers on the source material itself. Okay? Let's look at the next question. Name the global pressure belt that results from cold air at the 30-degree latitude. There's 30 degrees, the pressure belt, remember? And look at it below that. There it is here. So we're just identifying on the diagram and our answers are there. Okay? So obviously that's the subtropical high. Okay, so nothing at the moment is difficult. Everything is found on the diagram. Okay, let's look at the next one. The pressure belt is associated with thunderstorms and due to convergence of warm winds. Where there's a lot of convergence, let's look at it down here. We know we can see massive convergence at this area here. The air is rising. It's hot, so convergence of air, energy, it's rising. Immediately we know it's the equatorial region. And which pressure belt is at the equatorial region? The equatorial low. So in actual fact, this can be a very, very easy question. So that would be the equatorial low. So all our answers are found there. In this section, we should actually get total action if we use our source material properly. And sometimes we don't. We just want to jump to the questions first before looking at the source material itself. Let's look at another one. This was question 2, also from the 2011 paper itself. Again, there's information given. Refer to figure 2, which shows air movement in a valley. Already, the examiner is making you think katabatic, anabatic flow immediately. All right, choose the correct words from those given in brackets. Obviously, it's going to give you options, and you have to choose a typical type of geography exam questions. Same as that, we look at the diagram first. Quite a few hints here. Okay, number 1, we see the air moving downwards. All right, and from our studies, we already learned air moving downwards, katabatic flow or downslope flow. All right. We also note a little hint here. The moon and the stars. Immediately we know when we see the moon and the stars, it's during the night. We look at other diagrams. Remember, little letters or whatever given in your diagram is meant for a specific person. It's a purpose. It's related to the questions itself. So when the examiner puts B or A or C, he's actually referring to that point. B, it's found towards the middle of the valley. We know the thermal belt, okay? At the bottom here, we're not sure what the examiner wants there, but we know that when air comes down, it pushes the warm air up. We have sublimation, we could have frosts, we could have various factors that forming there. It's quite cold in that area. So quite a bit of information given to us here. Let's look at the questions then. The valley wind labeled A is a katabatic and adiabatic. And again, if we use the source material, we already worked out the answer. We know already it's katabatic. Okay, let's look at the next question, question 2.2. It says, this wind occurs during the day or night in the valley. And already, by studying the source material, we've already worked it out. The examiner has given us a tip. We see the moon, the stars. We've learned that already, that it happens during the night. So, makes our answer very easy. The following question, question 2.3, this also refers to an upslope or downslope wind. And again, we work that out by looking at the source material. We see the arrows pointing downslope. So, it's actually downslope from the source material itself. Okay? The zone labeled B is the thermal belt or frost pocket. And we go up again, and very clearly it's found in the middle of the valley. And we know already, we worked it out already by studying the diagram, it's a thermal belt. Okay? And the last question on this one here, 2.5, the form of precipitation experienced at sea is frost or snow. And we've learned already, we spoke about it by studying our work and looking at the diagram. We know sublimation occurring there. And of course, we've learned that frost occurs at the bottom of the valley itself. So that's frost. And what we're picking up so far with these two questions, that most of your answers are found on the source material. When we get these 10-mark questions at the beginning of each section or question, you understand, it's actually found very clearly in the information given to you. Okay? I'm going to analyze this diagram, and then, of course, we'll just take a bit of a short break, maybe answer one question. Okay? Let's look at this diagram down here. This is question 3, of course, question 1.3 on that 2011 paper. Let's see what information is given to us here. Number 1. We can clearly see, let me just go through the instructions first. Refer to figure 3, which captures the path and effect of tropical cyclone Yasi. Given us already what weather system it is. All right, weather phenomenon. It's a tropical cyclone. And it says the path. So let's look at this. We can see, number 1, it gives us the date and the symbol, so we know it's a tropical cyclone, and the arrows tell us it's moving in this direction. Okay? And we can see different dates, so the dates itself tell us that it's moving in that direction. We can see which area it's hitting, Australia. Okay? So basically, if we look at this diagram, it's basically showing us the movement and showing us the impact in terms of hitting, not really the impact in terms of the damage, but showing us when it hit. So it's basically dates and that. And we've got the last piece of information, Cyclone Yasi strikes Australia. Okay? Let's read through this article. Category 5 cyclone tears roofs. It talks a bit of the damage, and pubs. Okay? And houses, topples trees, and sends power cables crashing onto the roads. The residents of Australia are assessing the damage, and the largest Yasi is the largest tropical cyclone storm to strike Australia since the Europeans' first impact. So it's a great tropical cyclone. It must be huge, most probably a level 5. All right? Created winds of 280 kilometers. That confirms it's a level 5. All right, a very fast one. Look at the waves at 9 meters high. Okay? Thousands of the 400,000 people living in the path of 500 kilometers wide cyclone spent sleepless nights, all right, in hot and crowded emergency evacuation centers. Set up in primary schools, shopping centers, deemed strong enough to withstand the cyclone. It seems that they have buildings strong enough. Maybe they receive a lot of the cyclones in this area. The storm surge, there's another concept here, all right, which means piling up of your water, etc., along the coastal regions. Up to 8 meters high was experienced. On Mission Beach, power cables crashed onto the roads, and mature trees, palms, were toppled by surging winds. But local residents also reported an unusual half an hour in the eye of the storm. All right, you know the storm is calm, okay? And not much activity, the eye is calm, The storm is definitely not calm. The eye is calm. You've learned that already. So that's why it's unusual having a calm period between those two stormy vortices. It is the strangest thing to go outside and see the stars and there is no wind for half an hour. So our article basically described the effects of the tropical cyclone. It told us what measures, if you look at it here, all right, the effects, okay, it had. You can split it up. It told us some measures that were taken, okay, and it also told us about the strength and the evacuation. Oh, sorry, this is not the measures. The measures are here. Okay, it told us about the strength of the tropical cyclone, all right, and some of the measures that were taken to help the people. Okay, and again, it spoke about the devastation in terms of trees being toppled, and then also it spoke about a bit of the eye. So it's basically just giving us a few pieces here. Before we go to the questions on this section here, let's take a quick break, and you can get a quick glass of water and come back for the next exciting part. Welcome back, learners. The last part that we looked at was looking at the information about the tropical cyclone. We looked at a diagram and the information, and we classified the information also. Now let's look at the questions itself. Okay, the first question. On what date did Cyclone Yasi strike the coast of Australia? When we did an analysis of this question, we found people just looked at where the tropical cyclone was at first, and they looked at this and gave us this date, the 30th of January 2011. But we need to look at the question itself. It says, when did it strike Australia? And this is the one that it is. And that's clearly the 2nd of February 2011. So we need to be careful when we analyze our diagrams. And we see it's clearly shown there, 2011, 2nd of February. Okay, let's look at the next question. Name 2 conditions that would have favored the development of Yasi. I don't know, sometimes when we attach a name of a tropical cyclone, whoa, it sends students off. Now, how do we know about Yasi? How do we know what conditions caused Yasi? We put it sort of, it looks like an application question, but it's actually a low-order question. As long as you understand it's a tropical cyclone, it's generally the basic conditions of any tropical cyclone that you've learned in your notes. So, what would be the basic things? First one, temperature of 27 degrees Celsius and over. You've learned that already. Temperatures need to high because you need this air to evaporate, moisture to come through, all right, to create the low pressure system. You've also learned things like upper air divergence. Remember, you studied this, that you also need, all right, upper air divergence. I'm going to just draw a little thing down here. There's our line here. There's our air rising, okay? And it's subsiding and forming these clouds as it's rising, okay? And more air rises so the pressure can get lower, okay? In order for it to get lower, because we need extreme low pressure for the eye to form, for the air to rush in towards the eye. So visualize that air coming through, and it can't go up and it can't diverge. What's going to happen? All this air is going to accumulate there, and we're not going to have this low pressure getting lower and lower. So upper air divergence, all right? You've picked up things like latent heat. You know what's latent heat, all right? Heat that's lost when water vapor condenses. And that adds to the heat, and that makes it even a lower pressure down there. All right? You've also picked up a warm, extensive ocean, okay, which will give us a lot of humidity, a lot of condensation, a lot of latent heat. Also, less friction. Because you must remember the tropical cyclone occurs over the ocean. So, less friction over the ocean. All right? Or it originates over the ocean and then comes towards land. All right? Less friction over the ocean. By the way, please have a look at Cyclone Sandy. There's a lot of information at the moment, guys. Because Cyclone Sandy at the moment is wreaking havoc around the Americas, etc. So follow it on the news reports. Okay? It's quite interesting what's happening at the moment. So less friction over the ocean, which will also not allow the air to mix and destroy the low pressure itself. Because of temperatures, a massive evaporation. Okay, that will cause more air to rise, condense, give off heat, etc. There's so many factors here, guys. I will spend half this recording based on this, but these are some of the answers that you have. Obviously, you can refer to your notes. There's more. And of course, you give 2 of these facts, which gives you your 4 marks. Okay, it just mentions name, and not fully explain. Okay? So let's look at the next question. What evidence from figure 3 suggests that cyclones are common in Australia? Please note, the examiner asked you to refer to figure 3. All right? And that reference has to be made. If you're just going to give your general answers, we are not going to mark it correct. All right? First of all, in figure 3, we know that the name of this is Yasi. And we've already learned that cyclones are named. All right? According to the letter of the alphabet. A is your first one, B is your second one for that year. So Yasi is actually 25th. So many cyclones have occurred in one year. So that tells us that it's common. Also, we looked at this part I found that could be used. All right? They actually crowded in emergency evacuation centers in primary schools deemed strong enough to withstand the cyclone, which tells us that the buildings are strong. Why would they spend so much money building these strong buildings if they're not going to be affected by strong, devastating winds of the tropical cyclone? So those 2 again we found, together with our studying, answers in the source material itself. So, if I had to answer that question, it will basically be, number 1, the name Yasi actually tells us it's a 25th cyclone. Okay? Or the section on the buildings being strong to withstand all right, to withstand those strong winds. Okay? You don't have to use the exact words as I'm doing, I'm putting it down, but you also can use the exact words that's mentioned in the paragraph. So nothing very difficult at the moment. All right? Let's look at the next one. All right? This you would have studied. Again, to me, this is a lower order question because it asks you straight from the notes. Explain, what do you understand by a category 5 cyclone? Now, an interesting question, how do I answer this? I know that a category 5 cyclone is the strongest cyclone that exists. All right? That's the highest we can go. We've learned that. But that's just one factor. So when we come across questions like this, and we only can find one factor, then your option here is to give an example. Okay? So we can say it's the, first of all, a category 5 is the most devastating. Devastating. Right, I just smudged out my A and my T. My spelling is getting a bit damaged there. It's the most devastating cyclone. Okay, that's one of them. It's the strongest cyclone or whatever. We know a level 5 or category 5. And then we can give an example for the other 2 marks. All right, so for instance, causes extensive damage, let's say, to property. Or we can say to infrastructure. I hope you don't write like this, because it makes us hard to mark it. You write properly, not like me. You understand? Or loss of lives. You understand? There's so many answers that we can give here. Loss of lives. Or great loss of lives. You understand? Depending when it's a developed or a developing country, loss of lives. But there's various things when we give the impacts. You understand? Damage to the natural environment. We can go on and on and on. So the question like this, you explain it, it's the most devastating, and for the other 2 marks, you can give anything. You understand? In terms of showing what damages it actually causes itself. Okay? Let's go to the next question. Refer to the statement, local residents reported an unusual half hour in the eye of the storm. First question. Why do you describe the weather conditions in the eye unusual? All right? Now, already, when we looked at the article itself, we have some answers there. Okay? If you look down here, there was no wind. All right? We could see the stars. That tells us it's a clear sky. Okay? So we've got 2 answers here already, but just putting this down doesn't answer the question of why it was unusual. And this was the learners, they find these answers, say calm conditions, clear skies, because that's what's related to the eye. And they may not get their full marks. Remember, in geography, there's no vague answer. If the marks is 2, it's either 2 or 0. If you give vague, we can't give you 1 mark. So please note that, learners. It's very important to answer in full. Okay, we keep losing those marks along the way. So let's look at how we would answer. We saw those 2, then we can give even further. All right? Let's look quickly at it. Unusual. So it's important to say why it's unusual. Now, how would I describe it? All right? The sudden change. Because remember, the first vortex was actually creating massive damage, strong winds. All right? So we can say sudden change from strong winds and heavy or torrential rainfall. Okay? 2, we can talk about calm conditions. Now that automatically tells us it's unusual. We're having this massive amount of rainfall. Suddenly, it's actually calm. All right? Or we'll get 2 marks for that. All right? Or we could go to clear skies. All right? And we can go on to various others. I want to go to more questions. That's why I don't want to give you all that. You can actually refer to all your characteristics in terms of the eye itself, like very little or no rainfall, you understand, or slight drizzle, or no rainfall. You understand, there's so many options. But as long as you've compared it to the violent storms in the first vortex and then clear skies after that. Okay, let's look at the next question. Explain the cause of the unusual conditions. And when we drew the eye, we learned about, okay, I'll show you this one, that what happens, some of the air subsides, subsiding air in around the eye, and therefore the subsiding air brings about stable conditions, therefore it brings calm, etc. in that. So the answer here would be subsiding air, which brings stable conditions. Oh, that is why we have our clear skies, etc. Okay, let's look at the next question. What is the local name for the tropical cyclone in Australia? Now, I know it's quite a contentious issue because some of you go over the internet, etc., and find that this word willy is actually sometimes referred to as a dust storm, okay? And what you call it is, the cyclone itself is known as the tropical cyclone. Unfortunately, we stick with the textbooks in terms of this one, and in most places when we teach this section, it's known as willy. So stick with the original concepts, and I'm aware that this concept and explanation has changed. Okay? Why do you think Australia would have an efficient emergency program ready to handle natural hazards? Okay, here again, one of them you know already. They frequently have it. We have 25 cyclones already for that 1 year. So the large number of cyclones they have, large number of cyclones that they experience. Okay, all right, large number of cyclones experienced, and it's a strong economy. So they got the money to put into this, right? Some countries have a large number of cyclones, but they don't have the money. Or they are developed countries, developed country. Okay? So any of these sort of answers here would give you 2 marks. Before we go on to the next question, I'll allow you a quick break and a quick glass of water, and please return as soon as possible. Welcome back, learners. And let's start looking at the next question that I have. Again, remember, the source material first before we look at the questions. Let's not be trigger happy or question happy, as we can put it. All right, let's look at the next question here. Also question 2.3 from the 2011 paper. It says, study the synoptic map or weather map, figure 4, and answer the questions. Okay? Not much of instructions there because it's visible on the synoptic map itself. All right, very clearly on the synoptic map, we'll watch. There's some evidence here. We can see the mid-latitude cyclones there. All right, and we can see some symbols. B obviously will relate to the South Indian High. D itself is relating to the cold front. All right, C is relating to the South Atlantic High. We've got temperatures down here. It's emphasized here quite big, so it's showing us the temperature of, if you look clearly, it's around Durban. So bits of information given to us that are highlighted. There's a lot of other information here, but the ones we basically focus on is the ones that are sort of highlighted on the thing with letters, etc. So let's look at some of the questions itself. All right, I'm just going to go back. I think we went too far here. Okay. Right, the first question itself. Name the anticyclone labeled B. All right, when we look it up clearly here, there's B over here, and as indicated to the other synoptic map that I highlighted, the same one but highlighted on it, we know B is actually the South Indian High. Okay? Some of them call it the Mauritian High, etc. Generally, they know it's also correct, but we stick with South Indian High here. All right? Give a reason why pressure system B and C are known as anticyclones. Immediately you know the word anticyclone. It's associated with a high pressure system. All right? So the first one we could talk about, it's a high pressure system. Highest pressure found in the center. All right, because as we move away from the high pressure system, it decreases. Okay, I know this is a favorite one, and I want you to guard against this. It says it actually has air flows in an anti-clockwise direction. And learners quickly write this. Now please note, we need to emphasize the hemisphere. Okay, otherwise it's considered wrong. It's anti-clockwise in the southern hemisphere. And we'll use the southern hemisphere because it's showing us a map of South Africa, or southern Africa, which is in the southern hemisphere. We don't talk about the northern hemisphere in terms of this answer. Okay? Sorry. All right, and you can look at the general things about your high pressure systems. There's various other answers, etc. But any one of these would give you 2 marks. I'm sorry I'm not giving you the other options here, but there's so many questions we need to go through. All right, let's look at the next question. A group of students must go on a field trip to Durban. All right, on the day presented by the synoptic weather map. What temperature will they experience on the day of their field trip? It's this day on which the synoptic map was taken. Again, very clear. There's Durban, you need to know the location of Durban, and the temperature is given to you. So obviously it's 21 degrees Celsius. Quite simple if you use a source material. Okay, let's look at the next one. Briefly describe how front label D is formed. We look up again. It's a cold front. We know it. We can see the little symbols there. And we've already learned. Can you see sometimes relationship between questions? We've also learned at the first part when we did the tri-cellular, all right, that fronts like this are caused when fronts like this are actually caused when the cold air from the polar region meets with warm air from the subtropics. Okay? It's a meeting of cold and hot air. All right, let's look at the next question. Name the weather system labeled A. Be very careful, eh? When the A is in the center here, then it refers to the whole symbol and not just one of them. When they're on the sides, they refer to either the cold front or the warm front. So clearly, this is a mid-latitude cyclone. All right? That's your 2 marks there. Let's look at the next question. In which general direction does the weather system A move? Once you've identified it's a mid-latitude cyclone, you've already learned that mid-latitude cyclones move from west to east, or we can actually be more precise and say southwest to northeast. And that's our 2 marks. Any one of these 2 is fine. All right? Let's look at the next question. This is the one I highlighted already. Is weather system A, notice the lead-on questions also, all right, for you to have identified system A, likely to influence the weather conditions of Cape Town within the next 24 hours? Explain your answer. This question actually tapped quite a few learners, because they always had questions where you say yes, and it's going to hit, the temperature decreases, stronger winds. But if we look carefully at the diagram, there's the South Indian high that is ridging in, and it's blocking the cold front from affecting the country. Also, we look at if the cold front is moving, it's already very far south to affect the country, even if it moves up. And a huge part of the mid-latitude cyclone has already passed Cape Town, so it's going to move ahead. So we had to examine the diagram and realize that it's no, actually. It's not going to actually affect the country. So the answer is no. First one, all right, the South Indian high is ridging and blocking the mid-latitude cyclone from affecting the country. All right. Or another reason could be it's far south, as we showed you there. Okay. Or a big part of it is already a big part of mid-latitude cyclone already east of Cape Town. All right, telling you that it won't affect the country itself. So for this question, no would give you 2 marks, and any one of these reasons would give you another 2 marks. Let's look at this last question here. Of what importance are weather systems such as A to farming in the Western Cape? And I'm going to emphasize one word here. Farming. So our answer must be specific to farming. Again, we found quite a significant number of learners just went on to the effects, and it wasn't even related to farming. So it has to be related to farming. So we said it brings rainfall in winter, which is significant to farming, obviously. All right? And it will bring in a different type of crops or things being farmed, like what grows well in this Mediterranean climate of winter rainfall is your fruit, encourages fruit, okay, farming. And you know, one of the fruit farming, and I hope you guys are not doing that, all right, is the orchards and vineyards. Orchards and vineyards, okay? You stick to your studies, no vineyards for you. Okay, so just things like this. There's various other options also in terms of dams get filled up. You understand? So there's stored water for the summer time when there's no rainfall. So there's various things. And of course, if I'm going to write all this, as I say, I'm not going to finish more questions. So you get 2 marks for any one. And in fact, in filling of dams, storage of water, all those answers will give you 2 marks. Just one of them. Okay, let's look at the next question. This was quite interesting. It was question 1.4 on the 2011 paper. It shows us here an issue of climate's latest change, flooding linked to petrol use. Okay, in here also it talks about climate change and its effects. So already guiding you to what questions are going to be asked. Not so much information, all right, so a lot of it had to be interpreted by you and what's based on your studies. You can see this car being flooded here and lying in this huge pool of water. Driver is sitting on top, he can't go anywhere. All right, let's look at the questions. What do you understand by the term climate change? Okay, it's the change, you know the definition, change of climatic conditions over a period of time. Remember, these are concepts, and if you feel comfortable to use your own words, you can do so, as long as you don't change the meaning. It actually means the same thing. All right, let's look at the next one. Explain how it is possible for flooding to be linked to petrol use. Okay, now you've learned in your notes or when you and in class that the burning of fossil fuels when the car is traveling, number one, all right, it lets out a lot of carbon dioxide, okay, which heats up the air or atmosphere, okay, all right, and that actually causes more warm air rising. I'm going to put it here, more air rising, all right, therefore more cloud, all right, more rain. All right, another one easily would be, if you look at all these particles, these polluted particles of carbon dioxide particles in the air, creates more condensation. And nuclei. All right. For water vapor to cling to, you know, we need condensation nuclei for water to cling to actually form droplets of water, so therefore more rainfall. Okay? And there's various other reasons. All right? It creates more evaporation. All right? So any two answers here, I'm sorry I'm skipping you, but you can check the memos. There's various other answers in that. All right. Just I want to talk about one more thing that was quite interesting. All right. Where some of the learners wrote, and we had to accept it, because they looked at the diagram and saw that this guy was stuck there. So they wrote, and this was very interesting, they wrote that the car could not move. All right. Because it's jammed. Could not move. All right. Therefore, drivers could not buy petrol. Okay? It does relate, because basically the question was focusing on how carbon dioxide heats up, causes warming and causes more rainfall. The learners looked at the diagram, which made sense also. You can't go and buy petrol, so it cuts down the petrol use itself. Okay? Quickly, to look at just one more. All right. Sustainable measures need to be taken to address the challenges associated with flooding. Write a single paragraph discussing the possible solutions that municipalities can apply or employ to reduce the effects of flooding. I'm just going to go through a few because I think more or less our time is up today. All right. What can these people do to reduce flooding. And some of them there, and I'm sorry I'm going to go through it very briefly, simple answers that you've done before that make sense. Building of dams, plant more trees, straighten meanders, because if you're not straightening meanders, by the time the water curves, it floods the area. Channeling of rivers, creating new channels to move it away. Building of levees and artificial embankments of water, so that when you build a levee, it's higher, it actually holds more water. Widening of the river channels. You notice the amount of fluvial processes also coming in here. The sections are related. So you widen it, it holds more water. All right? But there's various answers here, and I'm so sad that our time is actually up, and we can't go through more questions. But I think the most important thing here, people, is that you've realized today, or you've realized during my lessons in the past, that it's so important to use the source material. Many of us just jump to the questions, and then we get answered incorrectly. We just relate it to our notes. But when we look at the source material given to us, we find a large number of answers are already found in the source material. And therefore, if we use that properly, it's easier to answer our questions. So, learners, do yourself a favor. Take those past papers over the last few years. Each one, take it as if you're sitting for an examination. Sit down, study the source material, and you'll find that it becomes so much easier. And that A that you thought was impossible becomes a huge possibility. So I hope that you've picked up a lot of information about using the source material today, and all the best in your studies. I know you're not going to let us down, and you're going to get that A. All the best, learners.